And welcome to my YouTube channel. So here today we are going to be looking at the term independent of x. So now how do we go about that one? So if you are new to this channel, kindly like, subscribe and share for more. Firstly, when you're looking at the term independent, we are looking at a term without x. So we have a famous formula which is our t r plus 1. I will explain. So should be equal to n combination of r. Then we are going to have our a n minus r b to the power of r, where if you have, let's say, if you have your 1 plus x to the power of n, let's say your n is 5, you are going to have your n will be 5 combination of r, which you don't know. Then you have your a, then you have your n, it will be n is 5, so you will have your 5 minus your r. Now for a, it is the first term, in this case it will be your 1. Then you have your b, which will be this one, in this case it will be your x to the power of r, like that. So that's that. Now why is it t r plus 1? So this r plus 1 tells you the term. Like for example, if you are looking at the term independent of x, you are looking at the term, for example, if you have if you are expanding, let's say the binomial expansion x plus 1 like that to the power 6, you will realize to say the first term will be n combination of 0. Then you have, let's say you have your 1 to the power 5 x to the power 0 like that, plus you have your n combination 1 times your 1 to the power 4, then you have your x to the power 1. It's continuing. So you can see that this one is the first term and its r is 0. This is the second term and its r is 1. So second term, first term, r is equal to 0. Second term, r is equal to 1. So from this you can establish that r is less than n by 1. So n minus 1. So not necessarily n minus 1, the position. So the term minus 1, that will be equal to your r, like that. So this is why we say the term you are looking for is r plus 1. That means to say if it is the first term, you will say that your r is 0. Your r, when it's 0 plus 1, that will be your term, which will be equal to term number 1. So term number 1 will have an r of 0. Term number 2 will have a r of 1. So it will be 1 plus 1, which will be term number 2, like that. So that's the formula for that one. So with that said, let's deal with this. So if we have our x minus 1 over x to the power of 8, if I'm not mistaken. So this one, using the formula term t r plus 1 should be equal to, we have our n combination r, a n minus r, b r. We are going to replace. We know that our n in this case is 8, so we are going to have our 8 combination r. Then our a is equal to x in this case, so the first term is your a, then to the power of your 8, n is equal to 8 minus r, like that. Then your b, which is equal to negative 1 over x to the power of r, which you don't know. Now term like that. Now one thing is, you want to eliminate x. So what do you do? First you split this. You are going to have your 8 combination of r, then you have your x, 8 minus r. Then this r can be distributed as negative 1 to the power of r. Then you have times your x. If x goes up, it will take the negative r. Or if you want, you can say negative 1, like that. Then we have our r, like that. So what do we have? We have our 8 combination of r. Then we have our x to the power of 8 minus r. Then times, we have our negative 1 to the power of r, like that. So then we have our negative 1 times r, it will be equal to x to the power negative r, like that. So all we want is this x to disappear. So this is our term that we are interested in, and this term. So since that's the term we are interested in, we are going to isolate them and multiply them and say the only way we can eliminate them, we are already multiplying them, so we multiply them. So we are going to say if we multiply this times the x to the power negative r, so we want a term that doesn't have x, so we are going to equate it to x to the power 0. Because why? We know that x to the power 0 is equal to 1. So that's why we equate it to x to the power 0, so that we can find the value of r. So we are going to say this times this, we keep one base at the power, so it will be 8 minus r. We have this minus r should be equal to x to the power 0. We cancel this, we cancel this. We are going to have our 8 minus negative r minus r. It will be negative 2r should be equal to 0. We take this value here. We are going to have 8 is equal to 2r. We divide 2, we divide 2. So our r value is equal to 4. So now, your t was saying r plus 1. So that means to say the term will be equal to, 4 plus 1, which is equal to term number 5. If your r is 4, your term is number 5. So now let's find the value. We now know the value of r for the equation that says x minus 1 over x to the power of 8. So we are going to have something that is like this. So t r plus 1, which we have established that it is term number 5, should be equal to n combination of r. Then we have our a, n minus r, br. So replacing, we have our n is this value, which is our 8, combination of r, which is our 4, then times our a, which is equal to, we have this x, so we are going to say x, n is 10, or n is 8, minus our r, which is 4, then our b is equal to our negative 1 over our x, like that, to the power of our r, which is our 4, like that. So we are going to find that it will be 8 combination 4. So this 8 combination 4 is the same as 8 factorial over 8 minus 4, 8 minus 4 factorial, then repeat the 4 factorial, like that, times your x, 8 minus 4 is 4, times negative 1 times 4, 1 to the power negative 4, negative 1 to the power 4, it will be equal to positive 1. Any number to an even number, as long as it's in brackets, it's always positive. Then we have over our value, which will be equal to x to the power of 4. So this and this cancel. So if they cancel, just know that you are doing the correct thing. So we have our 8 factorial over, we are remaining with 4 factorial times 4 factorial. So what we are going to do is, we are going to say 8 factorial is the same as 8 times 7 times 6 times 5 times then 4 factorial, like that, over the 4 factorial times 4 factorial. Why have we ended on 4 factorial? 4 factorial is the same as 4 times 3 times 2 times 1, which by leaving it like this, we haven't changed anything, so that we can cancel. Then we are remaining with 8 times 7 times 6 times 5 over 4 factorial is the same as 4 times 3 times 2 times 1, so that this cancels with that, we are going to get a 2. This cancels with this cancels with this, or we can, this cancels with this to get a 2. So what we are remaining with is just a 7 times 2 times 3 over 1. So the answer here, it will be equal to, so this is 5, not 3. So 8 times 7 times 6 times 5. So this is going to give us 2 times 2 times 5, that's 10. 10 times 7, that's 70. So that is the term independent of x, so it is the term number 5, like that. Let's look at another example. Let's say we have 3x minus 2 over x squared, like that. to the power of 18. So same approach for this one. We are going to say our t r plus 1 should be equal to n combination r, sorry, a n minus r br. So your a is this one. So we are going to say your n is the power, which is your 18. Combination of your r you don't know. Then you have your a, which is the 3x in brackets. Then our n will be equal to 18 minus r. Then our b will be equal to the negative of 2 over our x squared. Then the power is r, like that. So we have 18 combination r. We can split this by saying this is the same as 3 to the power of 18 minus r. Then we have our x to the power of 18 minus r. So it can be distributed like that. Then we have our b, which is equal to negative 2. We have negative 2 like that. We have our negative 2. It can also be split by raising it to the power r times this. When it goes up, it will be x to the power negative 2. Then the overall power is r. So it has gone up. That's why it's negative 2. So we are going to have 18 combination r. Then we have 3, 18 minus r, x 18 minus r. Then we have times our negative 2 in brackets to the power of r. Then we have negative 2 times r. It will be equal to x to the power negative 2r. So remember the same approach. We are just interested in this. So we are going to say x to the power 18 minus r times x to the power negative 2r should be equal to x to the power of 0. So this is going to give us a value that is equivalent to, we take one base, add the power, so it will be 18 minus r. Then we have minus 2r should be equal to x to the power 0, like that. So this and this one cancel. Then this is going to give us 18 minus r minus 2r should be equal to 0. So we have 18 negative r minus r, it will be negative 3r will be equal to 0. So 18 will be equal to, we take this side, it will be 3r. We divide, our r value should be equal to 6, like that. So that means to say tr plus 1 is equal to t6 plus 1, which will be equal to the 7th term, which makes sense. The 7th term will have an r of, the 7th term will have an r of 6. So to find the value now, we have the value for 3x minus 2 over x squared to the power of 18. We know that the formula is saying that we have n combination r, a, n minus r, br. So in this case, our n will be equal to 18. Combination of r is 6. Then we have our a is 3x. So we are going to have 3x to the power of our r. Our n is 18 minus our r is 6 in this case. Then our b is equal to negative 2 over our x squared to the power of our r is 6. So this is what we are going to do. Then our 18 combination r is the same as 18 over 18 minus 6 factorial. Then we have our 6 factorial, repeat it like that, times we have our 3 to the power of 8, 3 to the power of, 3x. Then we have 18 minus 6, that's 12. Then we have times our negative 2 to the power of our 6 over our x to the power of 2 times 6, like that. So what are we going to end up with? So we have our 18 factorial. So we are going to say 18 factorial over our 18 minus 6, that's 12 factorial, times our 6 factorial. Then we have times the 3 to the power of 12. We also have our x to the power of 12, so it can be distributed like that. Then we have times negative 2 to the power 6. That will be equal to a 64 like that, because 2 times 2, that's 4. So 2 times 2 times 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So that's how come we have a 64 there. So this one now, 18 will be 18 times 17 times 16 times 15 times 14 times 13 times 12. So 12 factorial, because we have a 12 there. Let's just move this a bit. So if we move it here, we have 12 factorial there. Then we have times 3 to the power of 12, x to the power 12. What are we forgetting down here? 2 times 6, that will be 12 like that. So we have this value times our 64 over our x to the power 12. So we cancel this, we cancel this. We have our over 12 factorial times 6 factorial. So to reduce, we are going to end up with this, and this cancels. Then we have our 18 times 17 times 16 times 15 times 14 times 13 over 6 is the same as 6 times 5 times 4 times 3 times our 2 times 1. Then we have times our 3 to the power 12. We are not going to do anything with this value, times our 64. So all we can do here is reduce some values, of which when we reduce, so 5 goes, we are remaining with 3. 4 goes, we are going to remain with 4 divided by 16, that's 4. If we remove our 6 goes, we are going to remain with 3 here. If we remove our 2, it will be 7. If we remove our 3, let's just cancel this. So we are going to remain with our 3 times 17 times our 4 times 7 times our 13, like that. Then we have times our 3 to the power 12 times our 64, like that. Okay, so this is our value. We can just multiply some values, like the 417 times 7 times 13. Okay, let's begin with our biggest values here. We can have our 17 times our 13, which will give us this times this, it will give us 21, 51. This times this, it will be 7, 1. So this will be 1, 2, remainder 1, 221. So we have this, and this is 221. So we write our 221. Let's multiply 221 by 7. This will give us a value of 7, 4, remainder 1, 15. So we have 1547. So we have multiplied this. Let's just multiply by our 4. If we multiply 4, we are going to get a 7 by 4, that's 28. 4 by 4, that's 16 plus 2. The 2 remaining from 28, it will be our 8. This times this is 20 plus the 1 remaining, it will be 21. So 1 remainder 2. 4 by this, it will be 4 plus 1 plus 2, sorry, it will be 6. So this is the value we are getting, 6,188. Now we are just remaining with, we have multiplied this. So let's just multiply with 3. So we have this value times our 3. This is going to give us 8 times 3, it will be 24. Render to, so 24 again, 24 plus 2, that's 6. This times this, it will be 3 plus that remainder 2, it will be 5. This times this is 18. So we are just going to expand it as far as that to give us our value, which we have said it to be 18, like this, times our 3 to the power 12 times our 64, like that. So now this formula is not only used to find the term independent, but you can also use it to find any given term. Like for example, let's find the third term in this expansion. So let's say we are required to find the third term. So if you're looking at third term, term number 3, r will be equal to 2. So the r will be less than the term itself by 1. So we are going to have the formula t r plus 1 should be equal to, we have our n combination r, a n minus r, b r, like that. So our n in this case is equal to 3, combination of r is 2, then we have our a, which is our 2x in this case, then we have our 3 minus our 1, like that, then times our b, which is equal to negative y to the power of r, which is equal to 2. So we have, this is the same as 3 factorial over 3 minus 2 factorial, then 2 factorial, times we have our 2x to the power of 3 minus 1, that's 2. Then we have times negative y squared, it will be positive y squared, like that. So we are going to have our 3 factorial over 3 minus 2, that's 1 factorial, 2 factorial, times 2 squared, that's 4, x squared, that's x squared, then we have times y to the power of 2, like that. So with that said, we are going to have our value, which will be equal to 3 is the same as 3 times 2 times 1 over, we have our 2 factorial is just 2, so this and this cancels, then we have times, okay, so if you look here, we are supposed to write minus 2, r is equal to 2, so minus 2 minus 2, which will give us 1 here. So 3, if we say 3 minus 2, it's 1. Then we have our 2x, not 2x squared. Yeah, so everything's okay. Then what we have is times our 2x, then we have y squared, because this times this, it will be 2xy squared. So we have our 3 times 2xy squared, which will give us 3 times 2, it will be 6xy squared, like that. So this is how we solve that one. Thank you very much for watching. Hope you would like, subscribe and share for more to avoid missing out this very powerful content. See you in the next tutorial.